Hi, welcome to the NFPA LiNK YouTube channel. This page is dedicated to answering any questions or challenge you have related to electrical and life safety. And we're going to use NFPA LiNK to do it. The easy to use digital access to NFPA codes and standards. Today we've been asked to review the important points of marine environments and boat slip. Let's get started. So from your desktop, you will go to the NFPA LiNK homepage. You will select the direct icon. We will go to occupancy. Then you will select marine environment. Then we will choose boat slip. And you will see we have a picture, and the first thing you see here is signage, which is the one thing that we want to talk about. Signs need to be all over in marinas. They need to indicate warning, potential shock hazard, electric current may be present in the water. And they must be suitable for the environment they are installed in. These are covered in 555.10. And here's a bigger sign picture of it. And they should have effective colors, words, so that they're easily recognizable. This is an aid to try to keep people out of the water, especially in freshwater situations. We're going to cover electric shock drowning as the next one, which is the signs that we just talked about are to try to prevent people from coming into contact with charged water. Now this water can be electrically charged, and it could be in an area because a boat might have leakage current. And if this vessel has leakage current, it could be getting in there. It happens more around freshwater due to the lack of minerals in it that would potentially cause the overcurrent protection to actuate, or the proper actuation of it. So freshwater is where this more frequently occurs. Now I want to point out that we have been able to add internal videos, as well as we have a marina risk reduction report. Now ESD, some of you might wonder, is electric shock drowning, and it's when a person that's in fresh water contacts the water that's charged with electricity, and basically they become paralyzed and then sink. That's why it's not a good idea to swim and work in water in those areas when there's charged boats, and you wouldn't want to be in the water. We'll click the back button. The next one we're going to go to is actually the boat hoists. Often you will see these boat hoists being used in and around marinas, and they will be required to have GFCI protection. Just an FYI, this review that we're going over today is based on the 2020 NEC. In the 2020 NEC, GFCI protection is covered in 555.9. In the 2023, it was moved to 555.35C. But it's very important when anything that has a motor or electrical connected to it and it's being used in conjunction with something that's wet, that it has GFCI protection. We'll cover that more in a minute. The next thing we're going to talk about is the shore power receptacles. And these shore power receptacles must be enclosed in a listed marina power outlet, and the enclosure has to be listed for wet locations, or installed in a listed enclosure protected from weather and mounted 12 inches above the deck surface and not below the electrical datum plane. We will cover the datum plane later. Single receptacles must be supplied from a marina power outlet or panel board by an individual branch circuit. Boats must be rated not less than 30 amps, and those that are 30 to 50 amps must be of the locking or grounding type, and that's in reference to the shore power receptacles. So the receptacles that are 30 to 50 must be of the locking type. Receptacles rated 60 amps or larger are typically a pin and sleeve. Again, these have and will require GFCI protection. We will cover that in just a moment. The next thing we're going to talk about is electrical service equipment and conductors. Now, the electrical service equipment is what provides power to the docks, floating buildings at marinas. It's not permitted to be installed on a dock or structure, and it must be installed on the shore, if you will, and it has to be located above the datum plane. It cannot be below that. So voltages can exceed 250 volts unless the facility has qualified personnel that service the equipment under engineering supervision. Then it can exceed 600 volts. It's also to note transformers need to be located so that the bottom of the enclosure for that is not below the electrical datum plane. And the transformer has to be rated for the environment. Now let's cover the electrical datum plane. The electrical datum plane is basically a specified distance above the water. So it's a specified distance, and that distance is actually covered in 555.3. These distances are covered in that. And that ranges 12 inches, some may be 2 foot if there's tidal fluctuations, not tidal fluctuations, 2 foot above the highest water level for the area under normal. So when you're wiring or looking at doing a marina, you will want to make sure that you find out where that electrical datum plane is so that you can properly locate your equipment and your wiring. That plays a crucial role in how these are wired. The next one we're going to cover is ground fault. So GFCI protection, and you'll see that right here. We'll click that, and you'll see that is covered in 555.33B1, and that talks about GFCI protection, which is basically there's 2 types in a marina. You will see GFCIs, which are a class A, typically tripping at 0.5 milliamps, and they're covered in 555.33B and 210.8. The other one you'll see is GFPE, which is ground fault protection of equipment, and that's covered in 555.35A3. And for shore power receptacles, these are set to open at currents not exceeding 30 milliamperes. If it is a feeder or branch circuit installed on docking facilities, they are set to open at currents not to exceed 100 milliamperes. So it just depends what's they're feeding, what it's going to. There were some changes in that in the 2023 that you would want to follow up with. The next one that we're going to talk about is leakage current. Some people may or may not be aware of this, but leakage current is basically an event that happens to the defective wiring in a boat or vessel that actually allows electrical to leak into the water and charge that water, and it is the root cause for electric shock drowning events. This is why marinas with 4 or more shore power receptacles must have a leakage current measurement device to test vessels for leakage current. And these must be operated by a person that is qualified to do so. They need to know how to use it. And they can use that to test the vessels and identify the vessel that's responsible for that particular issue. The next thing we're going to cover is shore power disconnecting means. And this is very important because the shore power receptacles need to be able to be disconnected. They need to be readily accessible, and they need to be able to isolate the boat from its shore power, and they cannot be more than 30 inches from the receptacle it controls. Now in the 2023 NEC, there is a requirement now for emergency disconnects that will remove power to circuits supplied by marina power outlets. And that can't be a breaker. It has to be an emergency disconnect, would be like a mushroom type or something that would be easily gotten to. This is so that the power can be de-energized. Let's say somebody's in an electric shock drowning event. People just naturally want to jump in and try to save somebody. And they need to be aware that they could be subjected to that ESD as well. And so what happens, they hit this emergency button, kills the power to that area, and then they would be able to successfully rescue the person that was in that event. The next thing we're going to cover is the wiring methods. Now, wiring methods are basically covered in 555.30 through 37 in the 2020 code, and they're requiring the wiring to be installed at least 12 inches above the deck or pier. They may need to utilize watertight or submersible connections if too close to the datum plane, and they must have proper grounding and bonding. We'll expand the read more, and you will see that they have to have support. Certain ones could be located on the underside of the pier if they portable cables, but they have to be properly installed, securely fastened, not subject to damage. They can't be where they would be chafed. There's a lot of intricacies on the wiring methods, and they are covered in, like I said, 555.30 through basically 37. We hope this review answered many of your questions around the marine environment and boat slips. Be sure to visit nfpa.org/link and give LiNK a try if you haven't already. As you just saw, LiNK is truly a window to productivity.